So, well, first I'm gonna explain the idea to you, and then we're
Mm-hmm.
gonna go about implementing it. So, give me a second.
All right.
You are right. That's great. I don't know how to make space. It's
Mm-hmm.
weird. Okay. So, pathfinding. Alright. I gave you a gist of it in the last class. At the end of the last class, when I told you how pathfinding would work, like it'll look at all the possible areas. Okay.
Right.
And then it's gonna decide which of them is already visited, or maybe which of them can be visited, or which of them leads to like out of bounds. You have a 2D
Yeah.
array. You have a 2D array. Okay. Should write it down. Let's say you have a 2D array of 4 by 4. Let's say 4 by 4. Okay. So that means 4
Mm-hmm.
rows and 4 columns. Okay.
Right.
Alright. 4 rows and 4 columns. So let's suppose you start from 0 0, and you sort of have a, let me, path was, I made it on my phone. Right, so let's suppose that we have a path like we start from the coordinate 0 0, okay, and we have a
Mm-hmm.
path like this: 0 0 1 1 0 1 0 1 1 0 1 1, and this is 3, and this is 0 1 1. And let's suppose we have to get over here. Can we get over here? Can we reach this?
Yes. Yes, we can.
How can we reach this from here?
We can find the coordinate for this, or we can like move a couple of steps down
Okay, let's
and
suppose
right.
we let's suppose we move down. Let's suppose we get over here. Now what? Now we can go
Mm-hmm.
over here. We can only move in the ones.
Yes.
We can't move in the zeros. So I'm over here. Now I'm over here, and I'm stuck. I can't go over here. There's nothing. Out of bounds. Out of bounds.
Yeah.
You can go back, but that will be like backtracking. It's like
Mm-hmm.
saying that my previous choices weren't yielding anything, so I just decided to go back and try something else. You get it?
Yeah.
It's like the first path you find, you move over there. Like it's like this, that you're at over here, and you say like, all right, the first possible path I find, like let's suppose we have a one over here as well, over here as well. Okay, so let's
Okay.
suppose it first sort of looks down rather than looking over here. So when it looks down, it's like, all right, I'm not gonna look over here. Okay, I'm just gonna go down. Okay,
Yeah.
it's gonna go down. Okay, and it's gonna mark it as visited. Okay, that I
Mm-hmm.
have been to this place now, and I haven't reached my goal. Okay, so it's gonna move down again. It's gonna mark it as visited as well, and then it's gonna move over here. Okay,
Right.
and this doesn't yield anything since we got stuck. So then it moves back. Okay, it moves back, and then it tries. to find a path over here, another path over here. Like maybe try to look over here, maybe try to look over here. Okay. If
Mm-hmm.
it tries to look over here, it's gonna say, all right, this was visited, so we won't try to go over here. Okay. This will only be a part of our pathfinding operation when we try to backtrack. Like when we say, all right, we didn't find a path, we didn't find a path over here, we didn't find a path over here, and we are visited from over here. So it's gonna go back. It's gonna backtrack. It's backtracking is different than finding a path. Finding a path is like finding over here, finding over here. This one is visited, so we won't take this one, and this one is the one we backtrack to from where we came.
Yeah.
Okay, so that's the whole thing. Okay, so now I've made a path. I've placed one over here, and now this becomes like this. Okay, you get it?
Right. Yeah.
So I
So you
can,
can't really like move anywhere else in this case.
yeah. Let me just change one more thing. How about I change this to a one? No, no, just keep this a one and make this one a zero. This one a zero.
And you can only move once.
Yeah. Yeah. You can uh, you can move like when you take a choice, when you find a possible gateway. It doesn't look for the
Mm-hmm.
best gateway. It looks only for a possible path. Okay, and it's kind of like inefficient since it tries to explore all the possible paths. Okay, so let's say
Mm, yeah.
if I have something like let me just think. Let me just think. If I have something like no, it's not gonna work. Yeah, it's, it just tries to look for the best possible path. Starts from here. Okay, let's say it's the start. Let's say it's S. Okay, let's say that is G. Okay,
Mm-hmm.
okay. So it'll start from here, and it'll try to go down since it finds the path over here first. Okay, let's just suppose
Yeah.
it finds this one first. Okay, then it finds this
Okay.
one since there's nothing over here, nothing over here, and then finds this one, and then there's like no possible moves left, so it goes back, and then it tries to find over here something else, maybe where it could go, but doesn't find something, and then it kind of tries to find it over here. It doesn't find anything, then it says, alright, we're going back, and then it tries a different path like this one. Okay, and then it says, alright, I'm gonna try to go down, but there's nothing down, so it's gonna say, alright, we can't go down, we go right. Since you've visited left, it's gonna go right. It's gonna say, alright, can I go over here? I can. So let's say I'll go over here, then I'll go over here. Okay, but I can't find a path. I actually can, sorry, and it can go over here, from over here, and over here, and over here. There can even be multiple ways to get to the same path. It can be like this, this,
Right.
this, 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 and this. This is more efficient. You can even find the best possible paths, like the smartest possible path to G. Okay, best possible path. But that is a different story, and that gets way too complex for right now. Okay, that is called searching via BFS. It uses a queue. It's a BFS method. It finds the shortest possible path. The shortest possible path. It's kind of fun. You get to learn it in your university. Shortest possible path. It uses a queue, and it's it's fun.
Right.
It's very simple. It's very fun. Okay, so you got the whole idea on how this would work out, right?
Mm-hmm.
अपना अपना खा ही लो भाई गेट से अपना अपना खाना खा ही लो
Yeah.
Hmm.
राइस लेकर आओ बहुत भूख लग रही है
Okay. So now we're gonna start with the code. Okay. It's gonna
Okay.
be a very very tough code. It's not gonna be easy. Not very very tough. It's gonna
Oh.
be
Okay.
like somewhat tough, but I
Okay.
just want you to tell me some of the checks that we'll have. Okay.
Mm, no problem.
What kind of base cases can we reach? Okay.
Yeah.
Base cases we can reach. It's fun. Recursion is so fun.
Yes.
Okay. Alright, so some of the base cases we can reach, right? What kind of base cases can we reach? Can you just give me an example of the base cases we can reach? Like, let's say I'm gonna give you one example. We found goal. That is a base case. Base case that returns
Hmm.
true. Okay.
The start can be a base case.
The start.
Yeah.
The start. I think so. The start is the base case. Base cases are when we cannot actually find the right path, or when we can find the right path.
Yeah.
Okay.
So
So
then it could be any one of those zeros and ones. That could be another base case.
yeah, when we can't find a one, let's suppose over here, that can be a base case. Okay. That is a case of failing. Okay. That is a case
Yeah.
when we fail. So there can be two checks for it. One is that we didn't find any one. Okay. And all of the
Hmm.
rest of them are like visited. And the second check could be that out of bounds. You get it? There is no path to go. There is no way
Right.
out. Okay. Stop. So if we're gonna talk about the code for this, okay, we're gonna have a boolean function. I'm gonna write it in programmers. So over here we are going to have the the function, the boolean function find path. So it's gonna look like this.
How we're making two public statics.
Public statics. The
Like,
pub
I mean, there's one public static void main
Yeah.
and a public static boolean. So
The
making
public static
another
the,
one.
the public static main is the main function, right?
Yeah, it's the main function.
Yeah, that is the main function.
Or a new function. I
Yeah,
see,
we're
I see.
creating a new
Okay.
function. We're creating a new function for the boolean.
Yeah.
Yeah.
All right, okay.
All right. So now we're gonna add our checks. Okay. So
Mm-hmm.
some of the checks that we'll have would be, one of those would be that we hit a wall. Okay.
Mm-hmm.
In a path finding we hit a wall. We're not going to explore that one. Okay. So we're gonna return from that. So let's just add one that we hit a wall. Okay. So that's gonna be like grid row and call and hit a wall. Oh, sorry, that's a zero. Okay. And it's gonna return false. Okay.
Right.
Great. So now we're gonna have another check, and that is gonna be our visited. Alright. So it's gonna be
Mm-hmm.
if, okay, we didn't create a class. We didn't create a visited, right? I forgot a boolean visited. If I'm not wrong. Okay, we
I
have
think
to
we
add some
did.
parameters over here. We have to have some other parameters. We have to add like int. No, no, no. Int goal. Actually, you have to add an int goal. Int goal row. Int goal call. You get it? Why we are adding the int goal and int goal row and int goal column?
Yeah, yeah.
Since we have to find the final answer and we can't actually do that without it, so it's gonna
Exactly, yeah.
be something that's gonna be there. Okay, so we're gonna have a boolean,
Mm-hmm.
right?
Mm-hmm.
And then it's gonna be visited. this boolean is gonna keep a check of all the places we've gone already, and we're not gonna pursue them anymore, right? So it's like this. Let me just go to my OneNote again. Okay, so it's gonna work like this. It's not gonna uh, just check all the. It's a bit different than what you think. You may think that it's gonna work like this. That we have a zero over here. Sorry, a one over here.
Mm-hmm.
We move. Okay, and we're stuck. Now all of these are visited. Okay. Now
Mm-hmm.
when we backtrack, then we're gonna say unvisited. Okay, we're gonna set this to unvisited. Since there may be another path from over here that may lead to goal. Okay, let's just suppose.
Right.
Okay, so yeah, there may be another path from over here that may lead to goal. So we're gonna mark it as unvisited. We're gonna mark this as unvisited, then we're gonna mark this as unvisited, and then we're gonna say like, all right, we're over here. Now we're gonna explore a different path since in our loop we kind of went this way first.
Yeah.
Give me 1 second.
Okay. Okay.
I'll be back in a minute.
Sure. Okay.
All right. I'm sorry about that. Actually, one of my family members, my aunt, had come out for
Mm-hmm.
the night and she was leaving. So I had to close the door.
Oh, I see. No problem.
Yeah.
I get it.
Yeah. Right. So yeah. Okay. So we have our we have our case for zero. We have our visited
Mm-hmm.
area. Okay. So I was explaining you something about how our visited area is working. Okay. So I'm just gonna give you a gist of it. When we are exploring any path, okay, from any node, okay, from over here, from over here, okay, when we are exploring our path, when we're exploring from S, let's suppose, okay, we start from, let's suppose, we may start from over here, we may start from over
Yeah.
here, we may start from over here, okay, any of the
Mm-hmm.
above. Let's say we start from the very top, okay, we start from the very top, we enter that function again via recursion, okay, with this new coordinate, that is the top one, okay, you get it.
Yeah.
Now we end up actually hitting one of our cases, which is the boundary check, which fails since it's out of bounds, right?
Right.
So we return false. Then we're like, okay, we couldn't find a path over here, so we're not gonna call the next recursion. Actually, we're gonna still loop around the directions for S, okay. So now it's gonna choose
Yeah.
over here and it's gonna do the same thing, it's gonna go out of bounds, right? Then it's gonna go
Right.
over here. Then it's gonna say, did I find a zero? Did I find something that's visited? Did I find an out of bounds? If all three conditions fail, then it's probably something that's a one. That is a possible way out, right?
Mm-hmm.
So we're gonna mark this one as visited, and then we're gonna say, all right, we marked it as visited. We are good to go. Now we're gonna explore all the possible paths to this one, right? So we're gonna go up, all right?
No.
Okay.
Okay, and we're gonna call in recursion for this going up, balas, like, okay, what are coordinates? Okay, so now what's gonna happen is that it's gonna work for this. It's gonna go in the function again with these coordinates. But now remember that this got visited, right?
Yeah.
Right. So this won't work. Then it's gonna try over here. Then it's gonna try over here, and find when this one is gonna go out of bounds, and this one is gonna yield us a one, right?
Right.
So we're gonna go over here. Now this was visited. This is marked visited. This was marked visited. They're marked visited like uh, before we start finding the directions, right?
Mm-hmm.
So these are marked visited beforehand. And then we have this one, and you get the whole thing. Now when we are over here and we can't find a path, we can't find somewhere to move, we go back, okay? And when we go back, we mark it as unvisited, okay? Then we
Right.
go back from over here, go back from over here, and all of these get unvisited, and then we come over here, okay? Now we start
Mm-hmm.
in a different direction of S, okay? We explored this direction. Oh, sorry, we explored this direction. Wait a second, what's happening? Why is the battery running so low? I'm charging it. Oh shoot, oh oh.
Oh boy. Yeah.
Wait, is it charging or not? Could you just tell me if it's charging? Okay.
I'll tell you. Sure. Yeah. Yeah. It is charging.
Oh, thank goodness. Is it
Oh,
now?
not anymore. No. No.
It's charging now?
Nope.
Oh my goodness.
Oh boy.
What's happening? What's happening? Why am I losing it?
Is it a symptom of you dropping your laptop?
No, this is not my laptop, this is the new laptop. This is because I'm using an extension.
Oh. Okay. Oh, it's charging now.
It's charged now?
Yeah.
Oh, the switch was loose.
Oh, I see.
This is a relatively new laptop. This doesn't
I
have
see.
any
I
of
see.
those
Yeah, you might
problems.
want to get the switch replaced then.
What?
You might want to get the switch changed.
Yeah, it's a socket that has the issue actually.
Yeah. Yeah.
The socket is like kind of loose with the extension.
Mm-hmm. I see. I see.
Yeah. Okay, so where were we? Damn, that was that was
Intense.
intense. Okay, so we explored this path and we kinda ended up returning false. You get it?
Yeah. Mm-hmm.
From all of this, we backtracked, and kinda when we reached over here and we couldn't find a path to G, we kinda ended up returning false from over here as well. You get it? Like false from over here, false from over here, and false from over here as well. You get it?
Yeah.
So now we have this path. Okay?
Okay.
Then it's gonna be like this, this, this. One is gonna explore like top, left, down. Okay? All of these are not gonna work out since this is visited, this is zero, and this is out of bounds, right? And
Mm-hmm.
then it's gonna go like this, right? Okay? It's gonna find a one. It's gonna say, all right, that's great. I found a one. Okay? And it's gonna go over here. Then it's gonna do this again, this whole thing again, and then it's gonna find a path over here. Then it's gonna find a path over here, the same way. Okay?
Right.
And we get to our goal. Now tell me which of the when we reach our goal, which of the ones are visited at that time?
Uh-huh.
What does our visited contain at that time?
The one.
No, what does our visited array contain at that time when we reach G? Think about it.
The directions in which we gone and how many times we moved.
Yeah, it's a one-dimensional array, so I'm pretty sure it won't. It's actually two-dimensional. Sorry. Okay, so
Yeah.
stores the directions. It stores the whole path. You get it?
Right.
It stores the whole path from here till here. You get it? This path. So you can
Mm-hmm.
use the visited area and you can say, alright, I found the path. This is our
Yeah.
path. You get it?
Yeah.
Yeah. Okay, that's great. So you got the whole thing right? Like in theory.
Yes.
That's great. Okay, so now we're gonna have a check for visited. We're gonna have a check for visited. Yeah. Okay. So if it's visited, then it must return false, right? Since we
It
already
should.
came
Yeah.
from that path. Okay? We can't go
Yes.
back like this. Okay, so we've had one for visited, we've had one for visited, we've had one for zeros. Tell me one yourself. Just tell me one. I don't need these. You know, when we only have an if statement with
Mm-hmm.
one line statement body, then we don't need the curly braces.
Oh, really?
Yeah, you didn't know that?
No, I didn't.
That's why I did it over here as well.
Oh, good, good.
Okay, so just tell me now what other check can I use? I've used two. Okay,
Yeah.
okay, sorry. Wait, which one of these was a comment? Am I doing it in C++ again? No, I'm not. Okay. Okay. So this one is found a zero. Okay,
Okay.
you can assume the zero as something like water, and you can assume the
Okay.
one as land. Okay,
Right, right, right.
great. So we're gonna
And you
have
can't
like,
jump. I was thinking, what if we could like
huh?
jump over the zeros and land on a one a couple of spaces away?
What do you mean? I didn't get you.
I mean, like, can you show the graph,
Yeah,
the
sure.
table again on OneNote?
Yeah,
So you know how like look at the second row for example. There is 1 0 1 1.
yeah,
So I was thinking, is there a way in which we can jump through the zero
like this.
and like through it? Yeah, like skip through it.
Yeah, we can't do that. We have to find a path with the
Yeah.
ones. So,
Ah, I see. I see. Okay.
but we can have like a thing, okay,
Mm-hmm.
which can uh, which can be like you have two jumps until you get to your G, and you can and you
I
be
mean,
like
that could work.
and you be like I'm like gonna jump this one, and then
Yeah, that's the plan.
when we don't even find after two jumps, then we're gonna say all right, backtrack from here. That can happen.
Hmm.
Okay,
All right. All right.
that can happen.
Interesting.
Yeah. So already visited. Okay.
Mm-hmm.
Already came from here. Let's just make it easy for. Okay.
Yeah.
Okay. So now, which other check do we have for a base case? Let's just think. What other thing did we discuss over here when we are deciding?
So there was the end, the G, that was our base case, and then the second base case was
Yeah, G is a base case,
any
correct?
one of the zeros.
What?
Any one of the zeros were, or like the numbers
Yeah,
is also
a
our
zero we checked for. There
yeah.
is one more. There is a boundary check.
Ah, yes, an out of bounds check.
Boundary check. Yeah. So there's the one for the goal. That is great. We found the goal. We found we found a way. Okay, so it's gonna be if our current row is equal to our goal row, and and okay, I'm still doing that. It's allowed, by the way. You can write an and directly in C++. By the way, that's right.
Oh, okay.
Yeah, you can just write an and. You can also do this. C++
Oh,
and
yes,
Java
yes,
are
yes.
very similar, by the way. They're very similar.
Ah,
Very similar
okay.
languages. Goal, goal. Okay.
Are they similar in complexity as well?
In complexity, C++ is harder.
Hmm, right.
C++
Yeah, I've
is
heard.
yeah.
I've tried C. I tried it like a few years ago. And I tried to make
C, with
like a
C.
pinball style
C is
game
even
with
harder than
C. Yeah.
C is even
C
harder
is
than
even
C++.
harder.
Yeah, C is
I
even
had
harder.
no experience. Just copy pasting code on VS Code from a website and like trying to understand what to do. Even that wouldn't work. And so it took like a week or so. And it was very a nightmarish week. Uh, and I eventually gave up. I was like halfway there. Yeah,
I
they were
can't
very
believe
tough
it.
lines.
I can't believe you tried your luck with C.
And this was long before I uh, started using Python. So like long before, this was like 4 years ago, and I was a lot less skilled in programming at the time. So like with that level of expertise, having jumped to C was a mistake, honestly.
Big mistake.
Yeah.
Okay, we have our visited. But would our visited not change? What if we force it? Should it? Send address. It should or it shouldn't. I think it should. No, it shouldn't. Shouldn't change. Okay, done. Sure if this works out. This line. Copy this. Okay, don't now. Just tell me why I'm copying. Okay, so we are finding all the possible paths. Here's negative one, negative one. Okay,
मिला दूंगा इसमें
and then there's a negative
Mm.
one zero.
ज्यादा तो बोले
No, there's a negative one, negative one. That can't be right.
अपनी डेट करा दे
Okay, we can't move with the negative one, negative one. It's gonna be a diagonal movement. We don't have diagonal movements right now. Remember,
Mm,
right?
right.
We only have
Yeah,
movements
yeah.
like this. And what else can we do with our movements? There may be other paths. I can't figure it out. Damn.
Hmm.
When I figure out the movements. Oh, sorry, I forgot the pluses. I was like,
Oh.
we can add one.
Uh-huh.
All right, and then we're gonna just say return true. Uh, right now, in my university, we are finding like we found in this semester we found things like it was much harder. Okay,
Mm-hmm.
than this. This is like so easy for me right now, and those things are like
Ah, okay.
so harder than this. They were like,
Right.
I'm just gonna give you information. Find all the possible paths. Okay, throw them in an
Mm-hmm.
array. Find the best possible path. Okay, find
Yeah.
things like it was more related to DFS and other stuff. Find an odd cycle. Okay,
Right.
like
Okay.
with an odd number of nodes. It's called a bipartite. Is bipartite, and there were
Mm-hmm.
things like there were a lot of things in graphs, and graphs are all like this. Okay, they're like this, but they're like much harder than this find path thing. Okay,
Right.
so
Yeah.
they're like the epitome of typical
Right.
recursive coding.
Right.
They make us work hard. They make us very hard, very hard.
Mm, yeah.
It's so bad sometimes that our teacher ends up checking the paper wrong.
Really?
Yeah, some of the teacher actually checked the paper wrong, and then we can't do anything about it, and then we have to sort of just take it in.
Oh boy.
Yeah,
I wouldn't take that personally.
yeah, it's something. I
I
really
challenge it. I still challenge and dispute the results.
it doesn't work that well in university. Our lab
Mm,
instructor
right.
was really great for data
Mm-hmm.
structures, and she was actually good at checking. And with her, I did really well. I got like 96% with her.
Oh, mashallah. Very nice.
Yeah, I'm kind of really happy about that. So now we're gonna have a
Mm-hmm.
backtrack. Okay, so it's gonna be a
Okay.
backtracking. Backtracking is like moving back. Okay,
Yeah.
so I don't want to confuse
Okay.
you. Moving back
Right.
since we ended up not finding the goal, the goal from all possible paths available. Okay,
Mm-hmm. Okay.
okay. So yeah, now we're gonna backtrack. So we're gonna backtrack and we're gonna do it like let me just think. How do we do backtrack? Okay, we're gonna set our visited row, visited call equals to it's true, right? It's true for when we find it. We didn't mark it. We forgot to mark it. Shoot.
Yeah.
We didn't mark it, right?
Oh, boy.
We didn't mark
Yeah,
it.
we didn't
Okay.
market that.
Yeah, we should mark it.
Right.
Okay, so we must mark it. We must mark our current. Okay. Visited row.
Mhm.
Wait, if we mark it right here, then it's gonna be always true. Wait. Then it's gonna go here and it's gonna say, alright, get out of here.
Right.
Gonna mark it over, mark it. Before we search for the directions, I'm gonna just mark it over here. It's true. And we're gonna unmark it. Okay. Okay, so yeah, I have a habit of saving and I just
Mm.
end up pressing Control S and it just does this thing. Okay.
Do you
Uh,
use VS Code more often
yeah,
or like Visual Studio?
I use Visual Studio Code, but right now
Ah, okay.
I don't even have an IDE since I deleted my Windows twice, and now I'm thinking to switch to Linux since one of my
Oh,
servers got
good, good.
damaged on my RAM. Yeah, it's kind of
All
like a
right.
forced move since I actually don't have a choice. I cannot have more than 8 GBs of RAM on my own laptop. This not this one on my
Mm-hmm.
own, and I need
Yeah.
something efficient as an operating system. It can't work otherwise. You know.
Are you experienced with using Linux before? Like,
No, I'm not experienced with using Linux, man. I know
I
why.
have used it quite a bit, so I would recommend you would try Linux Mint first.
Yeah,
It's a very familiar interface with Windows, so it's like
yeah,
a very beginner-friendly operating system.
yeah. I know. Ali also told me to use Mint. I'm gonna
Mm-hmm.
learn how to use Linux from you, Ali, probably.
Perfect.
Yeah, I don't have well, like the dumbest of ideas on how to use Linux. I want
It's
something like
pretty easy in general.
I wanna have something like dual boot since I have to also edit my videos. So yeah,
Ah, right, right, right. Yeah.
so something like a dual boot would be great.
Uh-huh.
Do you know
Yeah,
how to
that
do
can
a dual
work.
boot?
Yes, yes, yes. So like having both Windows and Linux in one hard
Yeah,
drive.
yeah. Okay,
That can
so
work.
let's just check this out if this is even correct,
Okay,
and let's ask it to make us a main. Okay, by the way, why
sure.
do you know why I used an if over here?
Um, no, not really.
Okay, so I use an if over here since this is the find path code, right? And
Mm-hmm.
over here, if it returns true, this find path, this whole operation, since it's a boolean, right? It's a boolean function. Since it
Mm-hmm.
returns true, I'm gonna just for you. I'm gonna just write it like this. You can even I kinda didn't care about you over there since you don't know how this
Okay.
actually is. If it returns true,
All
this
right.
thing, okay, it returns a value 1. And if
Yeah.
there is a condition of 1, condition which results in a 1 in an if statement, that always like makes an if statement true, okay? It makes it work.
Right.
You don't even need
Yeah.
this part, okay? You don't
Right.
need this part. You only need this part when you have a condition like something like let's say it's equal to 5 or it's equal to 7 or something like that, right? Okay,
Mm-hmm.
or something like maybe it's equal to a string, then do this. All right. But when it's like equal to true, then you don't even need the true part. You just need that part. Okay. Since
Yeah.
it's gonna work if it returns a one. Okay. And this is just checking if one is equal to one. Okay. If it doesn't, if it returns a false, then it's gonna be zero, which is not equal to one, which is true. Okay.
Right.
Okay. So great. So, just for your understanding, now what we do over here is that when we write this find path and this whole thing over here, and we call this, we are actually calling recursion implicitly. It doesn't appear as if we're calling recursion, but we actually are. Find path is our function, okay?
Mm-hmm.
And we call it for row, call minus one, goal row, goal call, visit it, okay? We
Right.
check,
Okay.
and then we go inside it, and we check it for all the possible ones, and for all the possible like directions, and when we enter a direction, then we hunt for the path over there, right? So if there is a possible path over here in this one, we hunt
Yeah.
further. Okay, we go into its function with the call minus one row as it is. Okay, and we try to hunt for it. Okay, we check all the directions in row call minus one, and then if it's like over here again, then it's actually in the real one, in the static one is call minus two, right?
Yeah.
So we're moving implicitly. You get it? And once we
Ah. Yeah. Yeah.
and once we don't find a path, then we backtrack and then we say, all right, we couldn't find a path in all of these. Okay, so now we're gonna just return false. You get it?
Right.
So we're gonna say,
Yeah.
okay, we're gonna backtrack now. Wait, you get it now?
Yeah. Mm-hmm.
So I'm just gonna pass it to an AI now, so it can create a main and check it. Maybe there's an error
Okay.
since
Sure.
it's a very large code, and I'm not
All
sure
right.
how perfect it is.
Uh-huh. That's fine. That's fine.
Yeah, if you weren't even fine with it, even then I'll just check it. I hope it works.
That should work. I think it's fine.
Alright, so check this code and tell me the issue. Also create a main for this code. I've gotten a bit used to this keyboard now. I'm getting to my real speeds.
Ah, that's good.
You can see that, right?
I can. Yes. Yes. You've
Okay,
been
so it
quite faster than last time.
okay, so it kinda had some issues. The find part when
Oh.
it
Okay.
doesn't have a return statement at the end. After all recursive calls, it should return false. Okay. No boundary checking the code will throw error windows when trying to move outside. I didn't I do a boundary check? Oh, we forgot the boundary check. What did we do?
Oh yeah.
We
Yeah.
didn't write it. We just said we missed our boundary check, and we were like, okay. Okay, so the boundary check is like this. Okay, so it's if
Yes.
the row is less than zero, or the row is greater than grid or length, greater than equal to grid or
Mm-hmm.
length, column is less than zero, column is greater than equal to grid. Basically, you don't know this, right? You don't know what's happening over it, or do
It's
you?
greater than or equal to the first index of grid.
It's basically greater than equal to. It kinda is checking the first row, okay, and it's checking
Okay.
the length of the first row, okay, like this,
Mm-hmm.
okay. So if you want to check the number of rows, then you do grid or length, okay. So it kind of counts downwards then, okay. But if you're gonna, I'm gonna make a sketch for you, okay. All right, let me just make a sketch. You'll get a better understanding of it, because I know errors is something you haven't no perfectly gotten it. Let's say we have an array, and I'm gonna make it a different kind this time. So just to illustrate, okay. So this is our array. It's gonna be like this, okay. This, this,
Yeah.
this, this, and this. Okay. So this is our array. Let's just suppose this is our 2D array. Okay, can you see it?
Mm-hmm.
Okay, so now when we do a, and let's say this is our grid, okay, just for the sake of it. Okay,
Right.
so now when we do grid dot length, okay, grid dot length, then we
Yeah.
then we check the length of all the rows, total number of rows. Okay,
Yeah.
okay, so how does that happen? It kind of goes into the address of grid, okay, and it has the
Okay.
address of all the rows. Okay, it
Yeah.
has the address basically of the starting row. Okay, the starting row, okay, and the starting column. And when we do a grid or length, it kind of explores the rows. Okay, it doesn't go on exploring these, since it's kind of like this. I didn't explain it to you in the start, since I thought you'd get confused, but now you've kind of matured in this point. It's kind of like this. I'm gonna just, I made a
Right.
sketch for it
Okay.
even in my channel. It's kind of like this. This is our let's say it's our starting
Mm-hmm.
grid start, and it has all the next. Wait a second, I'm not sketching it right. Mhm. It has. I'm gonna use a green. Okay. Okay. And okay. Hmm. Sorry about the very bad handwriting, very bad drawing.
No, it's fine.
I
It's
am
fine. It's
like so
fine.
bad at the drawing part.
Oh, oh, this is beautiful. Don't worry about it.
Okay, I'm just gonna redraw this one just for the hell of it.
This is it's a masterpiece.
No, very bad. I can't even draw a straight line.
Nah, it's fine.
Okay.
It's fine.
Okay. So when we are talking about grid, it's actually an address. Okay. So it's an address
Mm-hmm.
of this. Okay.
Okay.
And this is our like starting. Okay. This is our starting
Yeah.
address, and it stores the starting address of the first row. Okay. Of the rows in
Yep.
general. Okay. This is the row array. Okay. This is the row
Okay.
array, and in the backend it's working like this. This is the row array. Don't get confused with it though. Okay. This
Okay.
is the row array, and it has a data type of integer arrays. It has a data type of what? Integer
Integer
array
arrays.
pointers.
Right.
Okay. So it's kind of like having a data type of integer array pointers. So when we declare a normal one-dimensional array, okay,
Yeah.
declare a normal integer one-dimensional array, we kind of have it like uh, int arr, right? Now
Right.
arr is our address, okay, for that
Yeah.
array. So over here it has the address like this is like an arr, okay, and this is like another
Mm-hmm.
arr, and this is like another arr, and this is like another arr, okay. So when we kind of explore grid dot length like this, okay, so we kind of say okay, we're gonna search all the addresses, we're gonna search all the integer array pointers, okay. So it searches
Mm-hmm.
all the integer array pointers and counts them up, okay. So it
Yeah.
actually kind of counts the rows, okay, the number of rows, total number of rows. You get it?
Right. Yeah.
But when we do it like this, when we do it like grid 0 dot length, now it kind of dereferences it, Okay, dereferencing is like moving through the pointer and getting to the first value. Okay, you get it?
Right.
So now what happens is now we're here. Now when we do dot length, it's gonna count these. It's gonna count one, two, three, four. You get it?
Yeah.
Now if we do grid, sorry, grid, uh, one dot length. Okay,
Mm-hmm.
then it's gonna move over here. Okay,
Right.
okay, and then it's gonna go over here. It's gonna when we do a dot length, because this part, okay, this is the dereferencing part. Okay, these two square brackets, these dereference. So it's kind of like this. I'm just gonna explain. You can write it in another way. Okay, in C++ it works. I'm not sure if it works in Java, but it's like this. In when we are dereferencing, we can either use the square brackets to
Yeah.
dereference. Okay, and when you put a value
Okay.
inside of it, we are like moving down or we're not moving down. It's up to us. Okay, if we put a zero, then we're not
Right.
gonna move down. If we don't, then we are. And in actuality, we dereference with an asterisk. Okay, if we want
Yeah.
to dereference separately, then we dereference with an asterisk. So when we dereference with an asterisk, it's kind of like this. It's grid. Okay, it's the address, right? And then we do a plus zero, and then we do an asterisk. Okay,
Right.
so that works like this. That gives us the same answer as this. Okay, this
Mm-hmm.
and this are same. This is
Right.
the dereference sync thing, the dereferencing part. If we remove it, it's gonna do the same thing because plus zero does nothing. Okay,
Yeah.
but if we do a plus one, then it's gonna work the same way. Okay.
Yeah.
However, if we remove the dereference sync part, okay, and we just do a grid plus one, then we actually kind of move over here. Okay, we actually just move to this
Right.
part, this one. You get it?
Yeah.
So that's how it's working in the back end. So it's always like this for every type of
Mm.
language. That is something learned. Okay, so back to the backtracking. Okay, so you get it right now how it's working out. This is a
Yes.
square. This is a square. It's 4 by 4. So it doesn't matter which row we take. We can take one dot length. We can take two dot length since the size of the arrays attached to them are all the same. You get it?
Yeah.
Okay. So the size of the arrays attached to each row is the same. So it doesn't matter. You can choose any one of them. You can even write over here. If the size varies, then you can write row over here. Over here. Okay?
Right.
The current row, which is the current row, since you know that row is subtracted or added upon. You get it?
Yes.
So what did we forget? We forgot about our false. Oh, this one. We forgot about this. And
Yes. Yes.
if
Yes.
no power found from this cell, then we return false from this cell. So we forgot
Mm-hmm.
this, and we forgot this part. So we're just gonna copy this. I'm just gonna copy this whole thing. I'm lazy. Okay. Okay. Yeah, this is perfect. Okay. Let's try it.
Mm-hmm.
Okay, great. So we have our start over here. It's actually I think a 4 by 5. No, it's a 5 by 5. Sorry about that.
Ah. Okay. Okay.
It's a 5 by 5, and we try to find paths, and we actually find a path. Our goal position is 4 by 4, which is this one. Okay, it's a 4 by
Yeah.
4, right? Wait a second. Wait a second. Wait a second. No, it's this one. Sorry. It's 4 by 4. It starts from zero. This is zero. This is one. This is two. This is three, and this is four. Okay. Same over here. It's like
Mm-hmm.
one, two. Sorry, zero. It starts from a zero, then a one, then a two, then a three, and then a four. So it's over here. The goal position is over here. Sorry about that.